In this short video, I will be presenting the parameters that we have calculated and found for our planet, which is K2-205b. Our first parameter is the transit. The transit in astronomy is the passage of a small body across the disk of a larger body. In this case, the transit is created by our planet K2-205b, passing in front of its star. Professionals detect transits as they perceive a decrease in the brightness of the incoming starlight. This happens when the planet passes in front of the star and partially blocks some light. Two values are retrieved once the light curve is built, TT and TF. TT is the time of first and last sign of brightness variation observed. TF represents the time for which the brightness decrease is stable. This represents when the whole planet's surface is creating shade as seen on the picture. For our planet, we have found a TT of 22,920 seconds and a TF of 10,560 seconds. The second parameter is the depth. The depth is calculated using the light curve of our planet. It is simply a subtraction of the highest point and the lowest point on the light curve. Our calculated depth is 6.9963 times 10 to the minus 4. Planetary mass. The planetary mass is simply the mass of our planet. It is calculated by using the gravitational constant, the radius of K2-205b, the period of our planet, and some sphere relations. Our calculated mass is 1.3890 times 10 to the 18 kilograms. This can be compared to Earth's mass, which is 5.97 times 10 to the 18 kilograms. The planetary radius. This is simply represents the radius of our exoplanet. It can be found using the depth and the stellar radius. Our calculated radius is 19,824 kilometers, which can be compared to Earth's equatorial radius, which is 6,378.137 kilometers. The planetary volume. This parameter represents the volume of our planet. It can be calculated using the sphere volume formula with the found radius. Our calculated volume is 3.2633 times 10 to the 22 meters cubed. It can be compared to Earth's volume, which is 1.08 times 10 to the 21 meter cubed. The planetary density. This variable represents the consistency of our planet, giving a mass per volume ratio. Our calculated density is 4.25 times 10 to the negative 5 kilograms per meter cube. Earth's density is 5,514 kilograms per meters cube. Orbital period. In our context, the orbital period is the time taken for the exoplanet to complete one orbit around its star. Our calculated period is around 57 million seconds. We know this is not close to our actual value, but using our light curve, this is our result. The Earth's period is 31,536,000 seconds. Semi-major axis. This parameter is the furthest point between K2-205b and its star. It can be found with the period, the gravitational constant, and the mass of the star. Our calculated semi-major axis is 2.19 times 10 to the 11 meters. Earth's major axis is 1.49 times 10 to the 11 meters. Eccentricity. This parameter is a measure of how the orbit deviates from a regular circle orbit. A planet with an eccentricity of 0 has a perfectly circular orbit around its sun, and the opposite, an elliptical orbit, would have an eccentricity of 1. Our calculated eccentricity is 0.99991, which represents a very elliptical shape. And Earth's eccentricity is about 0.0167, which represents a more circular. Inclination. This parameter is a measure of how the plane of an orbit is tilted with respect to the plane of the ecliptic. If the orbit lies on the plane of its ecliptic, it would have an inclination of 0 degrees. Our calculated inclination is 89.82 degrees. Earth's inclination is 0.000 degrees. Stellar radius. The radius of the star with the exoplanet is in orbit. It is usually shown in proportion with the radius of the sun, of our sun. The star's radius is 1.077574 times the radius of our sun. This refers to the mass of the star where the exoplanet is in orbit. It is also in proportion with our sun. The star's mass is 0.95 times the mass of our sun. Stellar effective temperature. The effective temperature of a star is equal to the temperature of a black body that emits the same amount of luminosity. Also, the smaller the wavelength of light emitted by a star, the hotter it is. Therefore, by measuring its light wavelength, we can find the effective temperature represents the temperature on the surface of the star. Our stellar effective temperature is about 5,890 Kelvin compared to the Earth's effective temperature, which is 5,777 Kelvin. Stellar luminosity. The stellar luminosity is calculated in watt and represents the total amount of electromagnetic energy emitted per unit of time by the star. The star of K2-205b has a luminosity of 4.8170 times 10 to the 26 watt. The Sun has a luminosity of 3.828 times 10 to the 26 watt. The stellar radial velocity represents at what speed the star is traveling from our point of view. The value is positive if it moves towards the Earth, and the value is negative if it moves away from the Earth. To find this velocity, we need to measure the change of light frequency from the star. An exoplanet exerts enough gravitational force to create a change of direction for the star and therefore create a change of light frequency from this star. Our stellar radial velocity is about 19,701.06075 meters per second. Axial tilt. Unfortunately, the axial tilt can be found only on few exoplanets, and no mathematical formula was found. However, it could be found by searching for a spin-orbit misalignment in the habitable zone of its respective star. Habitable zone range. This parameter is characterized by the livable area distance from a star. The habitable zone for K2-205b is from 1.0549 times 10 to the 12 meters to 2.4895 times 10 to the 12 meters from the Sun. Planetary temperature. K2-205b has an average temperature of 11,811 Kelvin. Earth's average temperature is 288 Kelvin. Atomic spectra for atmosphere. We have determined that our planet only has a presence of hydrogen. Planet Earth has nitrogen, oxygen, argon, and water. Possible composition of planet. To do this, we should compare the density. Due to its really light density, we can assume that it is a gaseous planet. Our planet's calculated density is 4.2564 times 10 to the negative 5 kilograms per meter cube. Earth's density is 5,514 kilograms per meter cube. Seasons. Due to poor amount of information on the axial tilt of our planet, the presence and the amount of seasons could not be found. Atmospheric composition. Unfortunately, only hydrogen was found in the atmosphere. Therefore, no molecule could be found in the atmosphere. In conclusion, if we compare the most important parameters, such as temperature and density, we can see that our planet K2-205b is not habitable. As we can see, the temperature on our planet is 11,811 degrees Kelvin in average, which is clearly not habitable, and the density, as we can see, is less than 1 kilogram per meters cube, which gives us a gaseous planet, which it makes it non-habitable.